Hi, so this is the first update for the template. I've got it earlier than the block started, but basically it's something similar to what I had in block A, very bare bones. And I know bare bones means usually glfw and some utility math functions. But here you can see, the template. These are 512 by 512 by 512, so a lot of voxels. So it even when you generate noise, it's a bit slow. It's on the CPU, but it uses some SIMD stuff. I used the library for that, and I already implemented basic ray tracing light, which works pretty simply. Let me show you that. So okay, and we trace the ray. So we use for tracing the ray in a voxel volume, we use something called a DDDA. I'm going to attach the paper that describes how this works. Basically, it's an algorithm for traversing a grid of voxels fast, or as fast as possible when they publish the paper. And there may be some optimizations to that, but we'll see. If the voxel has some color, then if it doesn't have some color, that means we've completely missed any voxels. So we just print the sky color. Then this is the intersection. So assuming this didn't trigger, it means we hit something. So this is the point in the array where we hit. This is some chunk, ignore this. We compute the normal and we get the color of the voxel. We get the direction. This is the direction to our point light. Right now we only have one point light, and I can control where it is with this handy IMGUI slider. So you can see I can place it up, down, on the x-axis, so on. Yep. And that's our point light. We get a direction to that. Then we make a new ray called a shadow ray. Again, I've used a research paper that basically gave me this magic formula for calculating an intersection point for the ray. So you send the point, which should be as close as possible to the surface. This means the voxel, basically. You get the normal, and they basically, what they do, using some magic int float stuff, margin of error stuff, it's going to compute a new ray as close as possible to the surface without having a false positive, like starting the ray inside the voxel, and that means we are basically inside the voxel we started with, and it will get marked as shadow even though it isn't. Let's show this. So it's pretty easy. Let's just place the intersection point with the other voxel and the direction, and you'll see that some of them, you're going to get these weird artifacts, and that's because we have self-intersection here, and that's not good. Okay, this is we're checking if it's occluded. If it's occluded, like if it hits any other voxel, then we're basically having a shadow, and we're setting the color to black. I'm going to expand this, make it nicer, because this is like just a hard shadow and it doesn't have any attenuation and stuff. But yeah, I'm getting used to the template. It's pretty cool. I really love the noise generation part. Like this Perlin noise, Jesus, it's going to look so fun. And I probably need to lower this a bit, because 5, it's quite a huge world.